Hello math students, this video is going over the 2.3 Ready, Set, Go homework. The first part of the homework is dealing with fractional exponents. So we need to remember back to 8th grade math where we learned that if I have the nth root of x, that is just the same thing as saying I have x to the 1 over n. And then if I had an exponent inside of the root, that just becomes the top of my fraction. So we're going to use this to rewrite some roots with exponents. So I'm going to go over just a couple of them to give you some help in getting started on these problems. So number 2, I have the 7th root of s squared. So remember, once again, I said that x to the nth root of x to the a is just x to the a over n. So the 7th root of s squared is just equal to s to the 2 over 7. And that's all my answer would be for number 2. So number 1 and number 3 are very similar to that one. When I get to number 4 though, things get a little bit trickier because I have a number as part of my exponent. So what I'm going to want to do before I do anything else is I am going to rewrite that 8. I know that 8 is equal to 2 to the 3, because 2 times 2 is 4, times 2 is 8. So 8 is equal to 2 cubes. This is 2 cubed times r to the 6. Once I have rewritten the number as the power of a prime number, I'm going to go ahead and rewrite this as an exponent. So this 1/3, I can go ahead and distribute that exponent to the exponents that are inside the parentheses because all I have in the parentheses is multiplication. If there was a plus right there, I couldn't do that, but because there's no plus, I can distribute that exponent. So in order to do that, I need to multiply my exponents. So I know that 3 times 1 over 3 is just equal to 3 over 3, which is 1. So my exponent that I have on the 2 is now just a 1. When I multiply the exponents for the r, if I go 6 times 1 over 3 is 6 over 3, which is equal to 2. So my answer for number 4 is 2r squared. Number 8 is a little bit different because when I go and try and rewrite the 75 is 5 times 15. 15 is 5 times 3. So I could say 75 is equal to 5 times 5, or 5 squared times 3. So it's not just a nice single number with an exponent, but it'll still give us similar things as what we had when we did have a single number as our exponent. So I'm going to go ahead and rewrite 75 as 5 squared times 3, then I still have that x to the 6. There's really a 2 on my exponent right there because square roots are undoing exponents of 2. So I'm going to write this as 5 squared times 3 x to the 6 with an exponent of 1/2. And then I can go ahead and distribute that exponent to everything that is multiplied in the parentheses. 1/2 times 2 is just equal to 1. And then I have 3 to the 1/2. And then 6 times 1/2, and this 3x should have actually been a 3 right there. Anyways, so when I go and multiply the exponents for the x, 6 times 1/2 is 3. So that is my answer for number 8. 9 through 12, it asked me to rewrite each of these logarithms with a fractional exponent and then find the answer. So I'm going to do number 9. Number 10. Number 10 is very similar to what we did on 1 through 8. So I'm going to go ahead, I'm going to rewrite this as log base 2 of 4 to the 1 over 3. In 2.3, we learned about the power rule for logarithms that says if I have an exponent in a logarithm, I can bring that down to the front of the log. So I'm going to say this is just 1/3 times log base 2 of 4. And then 2 to the 4 is equal to 2 because 2 to the 2 is equal to 4. So my answer is that exponent. So this is 1/3 times 2, which is just equal to 2 over 3. So it'll be very similar for 9, 11, and 12. The next section is very much related to what we did on 2.3. So it's asking us to use the properties of logarithms to expand the expression as a sum. That right there means use the product rule. A difference, that means use the quotient rule. And or constant multiple of logarithms. So this means use the power rule. So I'm going to do a few of the set part of this homework. I'm going to start with number 14. Number 14 says find log base 5 of 10a. So I have this 10 and a are multiplied inside the log. So I can say this is just log base 5 of 10 plus log base 5 of a. So that's what our product rule says, is if I have things multiplied together inside of a log, I can rewrite it as 2 logs that are added together. I also noticed that 10 is just equal to 5 times 2. So I am going to actually rewrite this log as log base 5 of 5 times 2 plus log base 5 of a. And then I'm going to use my product rule one more time to rewrite this as log base 5 of 5 plus log base 5 of 2 plus log base 5 of a. I can now evaluate this first log base 5 of 5, because 5 to the 1 is equal to 5. So my answer to this is 1 plus log base 5 of 2 plus log base 5 of a. And there is my answer. So this is using the product rule. Number 16, I have to use the quotient rule because I have a fraction right there. So my quotient rule tells me that I can rewrite this as log base 5 of d minus log base 5 of 4. 4 is just equal to 2 times 2, or I'm going to say 2 squared. So I'm going to write this and say this is log base 5 of d minus log base 5 of 2 squared. My power rule tells me I can take this exponent bring it down to the front of the log. So my answer for number 16 is log base 5 of d minus 2 times log base 5 of 2. So log base 5 of 2 is not a nice integer answer, so I'm going to leave the log base 5 of 2 in my answer. Number 20, I have a root. I can rewrite this as log base 3 of w to the 1/2, like we did on the first section of the homework. I then have this exponent that I can bring to the front of the log using my power rule. So this is just 1/2 times log base 3 of w. That'll be my answer for number 20. Number 24 is a little bit more complicated because I have powers, dividing, and products, so multiplying. So what I'm going to do is I'm going to start by looking at the fraction. I'm going to split that fraction up and say this is log base 2 of x squared minus log base 2 of y to the 5 times w to the 3. So I can bring this 2 down to the front right now because the only thing inside of the log is the x squared. So I can say this is 2 log base 2 of x. However, I cannot touch these exponents over here on the second log until I split up the y and the w. So I'm going to use my product rule to split these up, but I want to put the product rule in parentheses because both the y and the w need to be part of the subtraction. So I'm going to write this as log base 2 of y to the 5 plus log base 2 of w to the 3. And then I can bring these exponents to the front of their individual logs. So I have 2 times log base 2 of x minus 5 times log base 2 of y plus 3 times log base 2 of w. And then I'm just going to go ahead and distribute that negative. So I'm going to make both things in the parentheses negative or subtracting. So I have 2 times log base 2 of x minus 5 times log base 2 of y minus 3 times log base 2 of w. And so that is my answer for number 24. Number 25, I want to convert between logarithmic form or from exponential form to logarithmic form. So that's 25, 26, and 27. 28 through 30, I'm converting from logarithmic form to exponential form. So for number 25, I have 2 to the 9 equals 512. So this is answering the question of what exponent do I put on a 2 to get 512? My exponent is a 9. Another way I can think about this, if I start with a 2, I'm going to go the long way around to get a 9. So log base 2 of 512 equals 9. So write the numbers down in the order that I went. Number 28, I'm going from log form to exponential form. So if I didn't have any of this 1/2 over there, if I didn't know what it was equal to, I want to figure out what exponent do I put on a 4 to get a 2. I am telling you that the answer is 1/2. So this is my exponential form. Similar to what we did on the last one, I can start with a 4, work my way around the long way till I get a 2. 4 to the 1/2 is equal to 2.